Students, let us discuss the remaining questions of lesson number 4, that is measurement of matter. So we have discussed up to question number 4th C. Now question number 4th D. What is meant by unified atomic mass? So this answer is very simple and it is also there in your textbook. So this answer is there in your textbook page number 50 at the top. Here unified atomic mass, you can see last two lines are important. So you can write this in your own words that unified atomic mass is used as a unit of atomic mass and it is called as Dalton and its symbol is small u, and one unified mass value is equal to 1.66 into 10 raised to minus 27 kg. So this much last two lines you have to write in your own words. Now next question is explain with examples what is meant by a mole of a substance. So this is also very simple question and this answer is there in your page number 51. You can say last paragraph and this box. You read this or you read a whole last two paragraphs and this much, then you will get the answer. So this is nothing but answer of question number 4, last one. Now question number 5. What is the name, write the names of the following compounds and deduce their molecular masses. So here you have to write their names and we have already discussed such type of problems in videos. So first you have to write their names like this: sodium sulphate, potassium carbonate, etc. Then molecular formula to molecular mass, that second step you have to do. So I will explain again to you how to do this. See, first one is sodium sulphate. So sodium sulphate molecular mass, for calculating sodium sulphate molecular mass, you have to take atomic mass of each of the constituent elements in this compound. So first is sodium, and how many sodiums are there? 2. So atomic mass of sodium into 2. Then how many sulfurs are there? 1. So atomic mass of sulfur into 1 plus how many oxygens are there? 4. So atomic mass of oxygen into 4. Now you have to add all this. So here atomic mass of sodium is 23 multiplied by 2. Atomic mass of sulfur is 32 multiplied by 1 plus atomic mass of oxygen is 16 multiplied by 4. So by putting the values here, 23 into 2, 32 into 1, 16 into 4, 64, then you will get answer as 142 units. So at last you have to write molecular mass of sodium sulphate is equal to 142 units. So if you think that every time atomic mass it is looking little bit bigger, so you can directly do like this also. Let us see other example. K2CO3, molecular mass of K2CO3 is equal to, simply you can write K into 2 because 2 potassiums are there. Then carbon is single, so C into 1 plus O into 3. 3 oxygens are there, that's why O into 3. So simply put the value of atomic masses here. K atomic mass potassium is 39, atomic mass of carbon is 12 and atomic mass of oxygen is 16. Now by doing all this calculation you will get answer as 138 units. So 138 unit is the answer of this. So don't write atomic mass in full words. This first example I have written in detail because I want to explain you, that's why. But while doing all other sums you can directly write like this: K into 2 plus C into 1 plus O into 3, like this. So in this way I have showed you how to solve these. You have to solve remaining. I have solved first and second one. Remaining you have to solve at your own. Now next question. 2 samples M and N of slaked lime were obtained from 2 different reactions. The details about their composition are as follows. So here sample M and sample N. So sample M mass is given 7 gram. Here mass of oxygen is 2 gram and mass of calcium is 5 gram. Second example, second sample is N, whose mass is 1.4 gram, mass of oxygen is 0.4 and mass of calcium is 1. So let us understand how to do this. So which law is verified by using this, you have to tell. So let us understand. Here first you should know what is meant by slaked lime. See here, slaked lime is nothing but calcium oxide. Calcium oxide samples, different samples are there. So actually we should know the ratio of calcium and oxygen in by weight. So in this compound, atomic mass of calcium is 40 and oxygen is 16. So what is the simplest ratio of calcium and oxygen? Is 5:2. So by dividing 40 and 60 by common factor, that is 8, we get simplest ratio as 5:2. Now we should know whether this ratio is remaining constant in sample M and in sample N. So let us see in sample M. We have seen in sample M the mass is 7 gram. So here we have written mass, sample M mass 7 gram, that is 7 gram of calcium oxide, that is slaked lime. Now what is the mass of calcium and oxygen in this 7 gram? Here also you can see it is given as calcium is 5 gram and oxygen is 2 gram. So here we have written the same thing, calcium is 5 gram and oxygen is 2 gram. So when we take ratio of calcium and oxygen, we can get simply ratio as 5:2 because it is 5 gram, it is 2 gram. So now we will see in the sample N. So here this ratio is matching with the original ratio of calcium and oxygen in calcium oxide. Now we will see what ratio is coming in sample N. So sample N contains 1.4 gram of total sample. Here we have written mass is 1.4 gram of CaO. Now mass of calcium is given as 1 gram and oxygen is given as 0.4 gram. So here also we have written 1 gram calcium and 0.4 gram oxygen. Now let us calculate the ratio of this. So for calculating the ratio, you have to multiply this or divide this by simplest common factors. So here ratio is 1:0.4 because calcium is 1 gram and oxygen is 0.4 gram. But this is not the simplest ratio. Here, for calculating simplest ratio, we can multiply it by 5. So when we multiply it by 5, on this side we will get 5 into 1 5, and 0.4 into 5, you will get 0.4 as 4 by 10 and 5 is as it is. Now about 5 1 is 5, 5 2 is 10, 4 by 2, that is 2. So here you got answer as 5:2. So you might think that why we have multiplied by 5. So here expected ratio is 5:2 and most of the chances of this ratio is also 5:2. That's why we have multiplied by 5. So first we have multiplied by 5 and then we got the simplest ratio, that is 5:2. So we are getting the same ratio which is expected in both the samples. See, expected ratio is 5:2 and in sample M also ratio is 5:2 and in sample N also 5:2 ratio is there. So this law is nothing but law of constant proportion. We have seen in different samples of a compound, the ratio of constituent elements by weight remains constant or same. So here we have seen expected ratio is this and sample ratio of Ca and O in sample M is also this and in sample N is also this. Means from different samples the ratio of weight of different elements in a compound is constant. So here which law is verified? From above data, law of constant proportion is verified, or above data proves the law of constant proportion. So I hope you understood up to this.